All right, so these are the evens that you had assigned on line 4 that might be a little bit tricky. I think you had number 4, but I think that one was pretty easy. So I've got these sketched out, kind of what it looks like in the book, and this one's interesting because it's going around the y-axis, okay, which means you have to think about the radiuses in terms of right to left, this way. So when you set up this integral, because this axis is vertical, right, you have to do it in terms of x, or in terms of y and not x, like you're used to. So we are going to integrate. Our limits are going to be our lower limit from 0 up to 4. So we're going to go from bottom to top here. Okay, instead of left to right. We're going to have our pi out in front. And then the radius is going to be determined by this purple line, right, which is this function. But I can't put square root of 16 minus y, or x, or dx here, because it's supposed to be dy. So you'll have to do a little bit of work, and of course this will be kind of ironic here, to solve this for x, right? So you're going to square both sides and get y squared equals 16 minus x squared. Subtract 16, you get y squared minus 16 equals negative x squared. You're going to take the opposite. So we have 16 minus y squared equals x squared, and then you will have plus or minus the square root of 16 minus y squared, okay? So this one up here is the positive square root. Okay, if it was underneath on this side, that would be the negative square root. You know, that's in line with this quarter circle. So this is your radius, the positive square root of 16 minus y squared squared. Okay, that's kind of nice because then the squares cancel the square roots, and you have 4 from 0 to 4 of 16 minus y squared is all you have to integrate by hand. Okay. I think that one is manageable by hand. Oh my God. Let me kind of get you the answer. Or, well, you can type it in and check in your calculator, but integrate it by hand to make sure that you're getting the correct positive answer. Okay? Number 10 is easier because they have already solved this function in terms of y for you. So you see how these axes of rotations are the same? Okay, so that means you don't have to go ahead and solve for x because in number 10 it was done for you. So you would think that they would assign this problem first and that one second, but what else? So we're going to have our pi out front. We have our limits, right, bottom to top, our 1 and 4. And then we're going to do this in terms of y, dy. And so this is your radius the entire time, right, from the axis of rotation out to the function would be this guy, basically minus 0. So you have negative y squared plus 4y squared. Okay? There's your setup. This one might be a little bit brutal by hand, but you can give it a go, see if you can grind it out. And then the last one is number 16. This one's, again, different because now our axis of rotation is a horizontal line, so that tells me, right, that I'm going to be in terms of x for this integration. Okay? So far I have this area sketched out and shaded. And I've got this line y equals 4, but it's not like I can do 0 to 4 up here because it's not a vertical axis of rotation, right? It happens to be horizontal. Okay? So I'm going to have to determine my lower limit, of course, is going to be 0, and then whatever this intersection point is, right, that's what I'm going to get for my right-hand line. So we're going to do 4 equal to 1/2 x cubed, right? Multiply both sides by 2. X is 2. Right, when you take the cube root. So this must be 2. Okay, I'm going to put my pi in front, and this time my radius is a little bit more interesting, right? So this is attached to my radius, so when I go ahead and draw in from my axis of rotation out to the outermost edges of what I'm integrating, right, it looks like the ceiling for my radius is the axis itself, and then the floor is the function 1/2 x cubed. So what should go in here for your radius is 4 minus 1/2 x cubed. Okay. This one you can definitely evaluate in the calculator, but this is what your setup should be. Okay. Good luck.